Hello everybody, this is Miss Moran and we're going to be working on our series and sequence unit video 7. This is our sigma notation video. So we're going to talk about how things are written in a sigma notation, our sequences are written in a sigma notation, and what it actually means. So let's get started. Okay, so we're going to be understanding the vocabulary of sigma notation and then expanding series using sigma notation. So these are the two things, the vocabulary and how to expand. Okay, so this Greek letter that we have here, I'm going to highlight in red for you. This is sigma. And what it means is it means a sum. It sums this sequence, 3n plus 1. And we're going to start where n equals 4 and end where n equals 9. So this tells us which terms we're actually going to be using. But it always implies adding. Okay, so sigma notation will always imply that we are adding these terms together. So I'm going to start by writing it pretty long for us, and then we're going to go ahead and clean it up. So when you're asked to expand, you're asked to substitute in the n value for each of the values between 4 and 9. So I've got 3, 4, and we're always using integer values, so you'll never be using any decimals or fractions that you're inserting. Plus 1, so that's the 4, 5, and then we've got 3 times 6 plus 1, plus 3 times 7 plus 1, plus 3 times 8 plus 1, plus 3 times 9 plus 1. Okay, so then I'm going to go ahead and add all of these together and sum to find a final answer. So this is I'm going to add all the single ones together, 1, 2, 3, 4, 5, 6. So I know I'm adding 6 single ones together. And then I've got 3 times 4, which is 12, and 3 times 5 is 15, 18, from 3 times 6, plus 21, plus 24, plus 27, and all of those can be added in your calculator. You can of course do this all in your calculator, but you might save a little bit of button pushing if you can do some of it in your head or on paper as I did. So I got a total of 123. Please feel free to check my work to see that I did that right. Okay, the next one here, same idea. We're going to go from n equals 3 to n equals 7 by substituting it in. So I will have 3 minus 1 plus the square root of 4 minus 1 plus the square root of 5 minus 1 plus the square root of 6 minus 1 and plus the square root of 7 minus 1. It will always be adding because the sigma means to sum. So this gives me the square root of 2 plus the square root of 3 plus the square root of 4 plus the square root of 5 plus the square root of 6. Now, none of these can be combined because they have different radicands. However, I can simplify the square root of 4. So I'm going to write my final answer as 2 plus the square root of 2 plus the square root of 3 plus the square root of 5 and plus the square root of 6. So you only have to simplify if it's possible. Let's continue. Okay, this next one, and this is a different way of doing this, but it really is the same idea. I'm going to start at m, and then I'm going to go to m plus 5. So on the top of my screen, I'm going to write down what that means. Now, in order, I would have m plus 1, m plus 2, m plus 3, m plus 4, and m plus 5. Now, that's the same thing as me counting 1, 2, 3, 4, 5, 6 because I'd be just adding 1 to each. So this is what I'm going to be substituting in for n. So it'll be 2 times m plus 2 times m plus 1 plus 2 times m plus 2 plus 2 times m plus 3 plus 2 times m plus 4 plus 2 times m plus 5. Now to clean this one up, I have to distribute. And what I notice is that each one of these is going to give me a 2m, and it's just the constants that I'm going to have to add differently. So if I were to expand, I'm going to have 2m. I'm going to grab another color. I'm going to have 2m once, twice, 3 times, 4 times, 5 times, and 6 times. So that gives me 12m. Oops, that's not very dark. So I have 12m because I have 6 of them along the way. Then this is going to give me plus 2, plus 4, plus 6, plus 8, and plus 10. So if I were to add all of that together, that gives me 10, 20, and 30. And that is my final answer. So if you come up with a strategy as to how you're going to sum it all together, it's not that bad to expand. All right, now this one's going to be a little more complicated, so I'm actually going to suggest that we're just going to expand it, and we're not actually going to simplify this one, and I'll let you know when you will expand and simplify, and when you're going to be allowed to just leave it. But I'm going to start with j minus 4 and end with j plus 1. So very similarly, I'm going to write this at the top so you can see which values we're going to be using. J minus 4, j minus 3, j minus 2, j minus 1, j, and then j plus 1. So it kind of works in reverse, but I am adding 1 because j minus 4, j minus 3 is 1 bigger. So let's go ahead and just substitute these in. 3 times j minus 4 plus 1, 3 times j minus 3 plus 1, plus 3 times j minus 2 plus 1. Oops, that should not be there. It should be a plus sign. Plus 3 times j minus 1 plus 1 plus 3 times j plus 1 plus 3 times j plus 1 plus 1. So again, I'm not going to ask that you go ahead and expand this or to simplify this, but this is the expansion of this sigma notation. Okay, for this one, we're going to go ahead and substitute in n equals 1 and end at 6. So again, I'm going to be substituting in for the n value 1, 2, 3, 4, 5, and 6. And we will simplify this one because it's going to be all numeric. 3 times 1 squared plus 1 plus 3 times 2 squared plus 2 plus 3 times 3 squared plus 3 plus 3 times 4 squared plus 4 plus 3 times 5 squared plus 5 plus 3 times 6 squared plus 6. So I want you to go ahead and to simplify that on your own, and maybe somebody can post the answer to that online so you guys can all share it, and we'll talk about it the next time we're together. All right, last one. We're going to start at n equals 7 and end at n equals 15, and I'm using absolute value here. So remember, absolute value just takes whatever's inside, and it's going to have the outcome of that be positive. So let's go ahead and just expand it together, and I'll let you simplify it on your own. So the absolute value of 3 minus 2 times 7 plus the absolute value of 3 minus 2 times 8 plus 3 times absolute value of 3 times 2, 3 minus 2 times 9 plus absolute value of 3 minus 2 times 10 plus absolute value of 3 minus 2 times 11 plus absolute value of 3 minus 2 times 12 plus the absolute value of 3 minus 2 times 11, or, oh wait, 10, 11, 12, 13, plus 3 times, absolute value of 3 minus 2 times the absolute, oh my goodness, I'm saying more than I'm trying to write, plus the absolute value of 3 minus 2 times 15. Okay. So again, go ahead and sum that up. Your result of that should be positive because we are just adding all positive terms here, but you need to take care of the inside of each of those and make sure that then you convert it to a positive number because you're taking the absolute value. All right, so the idea of this one then, of this whole idea here, is that we're going to be using the expansion of these sequences and we're summing them all together. So it'd be very similar to you doing S, like for this example here, if we did S sub 6 for this sequence, except this isn't arithmetic or geometric. So here we're allowed to look at sequences that are neither arithmetic or geometric, and we're able to sum all of the terms and the values of those terms as we continue through without using a special formula. We would have to expand. We will be able to talk about how we can enter this into our calculators, but for now you need to just go ahead and expand them by hand, and we'll move on from there.